Hey guys, this time we're going to clean and inspect the fully disassembled engine and decide how to proceed. I started by cleaning up the crankcase and the crankcase covers. For the two halves of the main crankcase, that included peeling off little remnants of the silicone gasket. I used a bamboo skewer to pick off the little pieces that were being difficult. I followed this up with an acetone wipe to ensure that the surfaces would be ready for a newly applied silicone seal. I also wiped out the crevices to remove any remnant oil and murky sludge. This took a while since there are two halves to the crankcase, but eventually I got them to look really good. The left and right crankcase covers were a lot faster since they had a papery seeming gasket that lifted right off and a lot less stray oil to mop up. From there, I consulted the recall work instructions, which said to check the engine oil strainer screen. Turns out there's a little wedge-shaped metal screen right here. For 13,000 miles, I'd say this looks really good. No metal shards or flakes, just a little muck. I cleaned it up with some acetone using a nylon bristle brush and then dried it out with compressed air. It goes back into the crankcase with the narrow end first and the little flange on the upside. One thing to be aware of here, this half of the crankcase still has the transmission stack in it, and there's literally nothing keeping it in there, so be careful how far you tip the crankcase. The stack will fall out, and then you'll have to figure out how all the pieces go back in. Don't ask me how I figured this out. Here's the exploded diagram in case you need it, like I did. Anyhow, inspect the strainer screen. Next up, the connecting rod bearing area and thrust washers. I assume this is talking about the interface with the crankshaft. Neither of the washers appear cracked or broken, and the whole assembly rotates freely with no perceptible freedom in other directions. The non-uniformity in coloration that you see is from the original fabrication, likely a heat treat step used to harden the steel that would need to survive lots of sliding contact. I'm going to say that the crankshaft and connecting rod are in great shape. Next up, the main journal bearings, specifically whether the silver colored outer plating has been worn away. This is a great way to visually inspect the super tight tolerances here. If it's silver, you're good to go. If you see copper, you've lost too much material. As luck would have it, I see all silver. That's great news for me because pressing out that bushing is probably really difficult, and pressing in a new one is probably even more difficult. The next step on the recall work instruction is to replace the countershaft oil seal. I don't know if mine is necessarily bad, but the part costs like $2, and replace is really the only right answer, considering the amount of work required to expose it. I don't have the replacement part yet, so I'll show that in a different video. Okay, so I've ruled out the crankshaft and journal bearing, which was my top suspicion based on the recall history for this bike and the feedback I got from my local dealership when they listened to the motor. My next most likely culprit is the piston and cylinder. Some of you even left a comment about the scoring that we saw when it was originally disassembled. Anyhow, let's clean up the piston and take a closer look. The black stuff on top is just carbon deposits, nothing surprising for 13,000 miles. The linear scoring on the inlet side of the skirt, however, is definitely bad news. When functioning properly, the piston has very little direct contact with the cylinder. Piston rings bridge the gap between the piston and the cylinder, and the sides of the piston glide on a thin film of motor oil. If there are ever some sort of oil-starved condition, that could allow the piston to scratch or wear on the cylinder. If that contact continues over time, additional damage will accumulate. At some point in this process, there will be excessive clearance between the piston and the cylinder, which will allow the piston to rotate about the wrist pin and whack into the cylinder. With the skirt whacking into the side of the cylinder with each revolution of the crankshaft, it can make an awful clacking or knocking sound. This is called piston slap. Long story short, I think that's what caused the painful engine sound that started this whole project. So to fix the problem, I just need to replace the piston rings, and cylinder. I'm also going to replace the wrist pin and wrist pin clips, since the one I have is over 13,000 miles old. And as long as I'm ordering parts, I grabbed a new countershaft seal and a replacement flywheel bolt to replace the one that I mangled a couple of videos ago. I shopped around prices a bit for that specific list of OEM parts. The dealership wanted about $225, Riva Motorsports wanted $207, Bike Bandit would sell me the whole package for $182, and the winner was Partzilla with the lowest price of $161. I placed the order late in the day on a Friday and got notified that the parts shipped on the following Monday. Should be here any day now. The next couple of videos will be the reassembly process. Wish me luck!